Chemistry powers today, but courageous chemistry is shaping our tomorrow. It's fueling the hydrogen economy and driving clean energy. It's in our semiconductors and even powers our 5G. It makes bridges stronger and medical equipment safer. Chemistry powers progress and binds us all together. But there's something more that sets us apart. Courageous chemistry.
Welcome to today's lesson. In today's lesson, we will look at electrochemical cells, okay? What is an electrochemical cell? An electrochemical cell is a cell in which chemical reactions is used to produce what? Electricity, is it not? Yes, or we can say in which electricity is used to initiate what? A chemical what? Reaction. So it is in both cases because there are two main types of what? Electrochemical cell. We have looked at the first one in our previous lesson, which is called the electrolytic what? Cell. Focus for today is the galvanic or voltaic what? Cell. Okay? You can see the diagram that I'm having right now. The diagram that I'm having right now is an example of electrolytic cells, you know, in which a direct source of current is required, such as a battery, to initiate what? A chemical what? Reaction. This type of reaction, we say it is non-spontaneous. But when we talk of the galvanic or voltaic cell, we are looking at a device that is able to generate electricity through a spontaneous redox reaction. Okay, so we can say that a galvanic or voltaic cell is a device that converts chemical energy into electrical energy through a spontaneous redox what? Reaction. A very good example is the battery you are seeing here. The reaction occurs without initiation and it is a redox what? Reaction. Okay, this is the setup for a galvanic cell, okay, or voltaic cell. Now it consists of two half cells connected by a device known as a salt bridge or a porous barrier. Okay, one of the half cells is called the oxidation half cell, while the other one is called the reduction half cell. Now we know that at the anode it is where oxidation what? Occur, and electrons are what? Produced. These electrons can be observed by the connection to what? A voltmeter. The deflection of the voltmeter tells you that electron is actually what? Passing through. And the other end is called the cathode, where reduction what? Occur. Is it not? Here we are the electrode in which the electron produced are consumed. Okay, then these two half cells are connected by a salt bridge. Now the salt bridge, also known as a porous barrier, allows the movement of ions between the two half cells in order to maintain charge neutrality. It also prevents the mixing of the two electrolyte what? Solution, and we say it completes the what? Circuit. What did I say? It completes the circuit. The salt bridge can be made with a variety of different salts. Okay, it can be potassium nitrate, it can be sodium chloride, it can be potassium chloride, which is in this case, is that not? Yes. So just take note of it. Okay, the spontaneous reaction occurring in a galvanic cell such as a battery is due to what we call the electrode potential of the element, in this case zinc. Now zinc has a more negative electrode potential, okay, because it is more reactive in the reactivity, or called the electrochemical what? Series, is it not? Hence you see electron moving from where? The zinc to the where? To the copper direction. We represent this using cell notation. Now in the cell notation, the first line is called the phase boundary, okay, between the zinc and its electrolyte, while the middle two line is used to represent the salt bridge, and then the last single line is called the phase boundary for the what? Reduction reaction. Okay, take note that On your left, you will have the oxidation reaction. At the middle, you have the salt bridge, which is the symbol there. And then at the right, you have the reduction half cell reaction. As usual, I will balance charges and cancel out, okay? Watch this video to learn more about the galvanic cell.
A useful galvanic cell can be constructed by using zinc and copper. The anode is a zinc bar placed into a zinc sulfate solution, and the cathode is a copper bar placed into a copper 2 sulfate solution. The two solutions are connected by a porous sodium chloride salt bridge that prevents the two solutions from mixing but allows ions to migrate. Attaching a voltmeter to the cell shows that electrons flow from zinc to copper. The voltmeter reads 1.103 volts. Because zinc is a more active metal than copper, it is more likely to lose electrons. For this reason, the zinc bar is oxidized, producing a zinc ion and 2 electrons per zinc atom. The copper ions in solution gain 2 electrons and are reduced to copper metal. As the reaction continues, excess positive zinc ions build up in the zinc solution. At the same time, the loss of copper ions from the copper sulfate solution creates an excess of negative sulfate ions. Positive sodium ions migrate into the copper sulfate solution from the salt bridge, while negative chloride ions migrate from the salt bridge to the zinc solution and maintain neutrality of the solutions. The reaction stops when the zinc bar or copper ions are depleted. The overall cell reaction can be written like this.
Let's now look at examples of galvanic cell. There are two main types, the primary cell and the secondary cell. The primary cell is a type of cell that cannot be recharged. Okay? It cannot be recharged because the chemical reaction that takes place is irreversible. Alright? Examples are the Daniell cell and the dry Leclanché cell, or what is called the Leclanché cell. The Daniell cell consists of a zinc rod and a zinc sulfate solution as the anode, and a copper rod and a copper sulfate solution as the cathode, separated by a porous pot which serves as the what? Salt bridge. Of course, zinc is more reactive than copper, is it not? So similar reaction as you watched in the video will also occur in this Daniell cell. Now for the Leclanché cell, the anode is also made of zinc electrode, but the cathode here is made of graphite electrode, which is the only allotrope of carbon that conducts electricity. You remember, ammonium chloride is now taken as the electrolyte, while manganese oxide acts as a depolarizer. The secondary cells are cells that can be recharged. Okay, they are rechargeable due to the fact that their reactions are what? Reversible. Okay, unlike the primary cell that you cannot recharge because the reactions are what? Irreversible. Examples of secondary cell include your lead acid accumulator battery, which is also called your car battery. You have your nickel cadmium battery. You have your nickel metal hydride battery. You have your lithium ion battery. Then you have your lithium polymer battery as well. Okay, all these batteries work on the same principle. They are rechargeable because current can be used to reverse the reaction that has occurred. Okay, difference between primary and secondary cells. Of course, the primary cells is non-rechargeable, is it not? And it is also what? The reaction is what? Irreversible. Why the secondary cell is what? Reversible. Is it not? The reaction in secondary cell is reversible and it's what? Rechargeable. How is it reversible? Current can be used, is it not? To drive the reaction in the opposite direction. Alright, that is the reason why it is what? Reversible. Take note of that. Let's now see what happens within primary and the secondary cells. Okay,
Of what happens to the primary cell. The anode loses electrons to the cathode and both connected by a wire. Here the cell generating electrical current, but when the battery is run out of reactants and almost they all turn it into products, the cell stops working and it can't be recharged again. So here is an example on primary cell, which is dry cell. Dry cell battery is a voltage-producing battery containing the electrolyte chemical in the form of a thick paste. It produces voltages of about 1.5 volts. In this diagram, which represents the parts of a dry cell battery, the zinc casing provides enclosing to the electrolyte and the cathode as a whole. Ammonium chloride is the electrolyte used in this type of battery. Just ahead of the electrolyte lies a manganese dioxide, separated from the electrolyte by a separator. At the center of the cell battery lies a carbon rod, which is the cathode, and zinc casing is considered as the anode. So let's understand how it works. Every portion of the battery device has chemical reactions occurring within. While a reduction reaction occurs at the carbon electrode, oxidation proceeds at the zinc casing, which is the anode. The chemical reactions that define the entire energy process are as follows. At the anode, zinc loses 2 electrons and is converted into zinc 2+ ion. The ammonium ion from ammonium chloride reacts with the 2 electrons to produce ammonia and hydrogen gas. The manganese dioxide near the cathode reacts with hydrogen gas liberated to form manganese 3 oxide and water. Combining equation 1 and 2, we get the following equation. And combining all the above equations, we get... Due to these reactions, chemical energy gets converted into electrical energy. This energy then flows from the battery to the connected device through the outer circuit.
Let's now look at the difference between the galvanic or voltaic cell and the electrolytic cell. The galvanic cell, the cathode is the positive terminal or electrode, while the anode is the negative electrode. But for an electrolytic cell, the reverse is the case. For an electrolytic cell, the cathode is usually the negative electrode, while the anode is the what? Positive electrode. Now, the reaction for a galvanic cell is spontaneous, is it not? Yes, does not require an external factor to initiate it. While that of the electrolytic cell is non-spontaneous. There must be a direct passage of electric current or voltage to initiate an electrolytic cell reaction, is it not? Yes. So that is the major difference we have between the electrolytic cell and the galvanic cell. Other difference, you can see that we don't have a salt bridge for what? An electrolytic cell, but we have a salt bridge for a galvanic cell, is it not? Yes. Now, it is important to note here that be it a galvanic or voltaic cell, red cat holds. Okay, red cat simply means reduction is what? At the cathode, and of course, oxidation will be at the what? Anode for both cells, so it's similar. Alright, that now brings us to the end of today's lesson. Okay, do your other activities. I'll see you next class.